Hello, everybody. Welcome to Oracle Database World 2021, and welcome to this session on Exadata new features and functionality, where we will be taking you on a tour under the hood of Exadata. My name is Subban Raghunathan, and I'm VP of Product Management of the Exadata product line. And later in this session, I will be joined by Kotanda Uma Mageswaran, who is the Senior Vice President of Product Development in the Exadata product line. Exadata has been in the market since 2008, and we are right now on the 11th generation of this product. The vision for Exadata has pretty much remained the same over the last 12 years, which has been to build a platform that will deliver extreme performance and availability for Oracle database environments at the lowest cost possible and be available with multiple deployment models. We have delivered on this vision, as I said now, for the 11th generation over the last 12 years. And it consists of ideal database hardware, which are composed of Oracle's designed x86 servers that form both the compute as well as the storage infrastructure. And we build a networking fabric around these systems that boast the highest levels of reliability as well as security, while they build in the components that are required to deliver that maximum performance that I talked about. We combine this hardware and engineer it with software that consists of specific algorithms that are unique to Exadata that accelerate OLTP, analytics, as well as consolidation. Since we own the entire stack, both the hardware as well as the software, including the operating system and the hypervisor layers, we build in automated management capabilities that greatly ease the management of the infrastructure as well as the database itself. And we optimize this end to end while making it available on premises in a classic deployment model or as a cloud service where you can subscribe to the Exadata system, or a combination of those two where the Exadata system is available as a clouded customer model. The software algorithms that I talked about can be broadly classified into accelerations for OLTP, analytics, and features that enable very high levels of database consolidation. On the OLTP front, we incorporate hardware elements such as RDMA over converged Ethernet and the combined software and firmware drivers to make RDMA really play a big role in accelerating OLTP performance. We also included persistent memory as a new caching tier with the release of the Exadata X8M platform that delivers extremely low latencies for RDMA operations. Given the fact that we have got deep visibility into the various kinds of workloads that Oracle Database is trying to perform on the compute tier, we also can now prioritize traffic between those that require extremely small, low latencies like OLTP transactions versus those that require extreme bandwidth, which are mainly for analytics and throughput requirements. We also use RDMA to detect and recover from failed or sick hardware components. On the analytics side, we have introduced SmartScan many years ago and have continued to develop on those algorithms and make the smartness of the storage tier even smarter by offloading SQL queries to the storage and the compute elements that are present in the storage. We also have unique Smart Flash cache and storage indexing algorithms that automatically accelerate database I/O. We then take unique columnarized data structures that greatly speed up SQL processing and query processing, and we extend those formats directly into the flash of the storage tier, thereby giving a much larger footprint for memory-based or memory-intensive SQL processing. I talked about some of the consolidation algorithms that we build in. These consolidation algorithms allow us to uniquely prioritize latency-sensitive workloads from other bandwidth-sensitive workloads throughout the stack. And we also incorporate unique workload isolation capabilities where you can have multi-tenancy built into the platform that keep different workloads isolated from each other. Many of our customers, a full 87% of Global Fortune 100 today, have been taking advantage of Exadata across the various generations. And today, I'm also proud to say that 44% of the largest companies are running on Exadata Cloud, building and deploying the most mission critical applications and delivering to their customers a reliable and secure service through the Exadata system. The Exadata itself is capable of pretty much any given workload can be running on that Exadata system, and that will be running in a fast, secure, and reliable manner. But the most exciting news of today is that we are going to be talking about Exadata X9M. This is the latest generation of the Exadata platform that we released on September 28th, 2021. And this system has got the maximum performance that is comparable to an all in-memory system, but yet it simultaneously gives you the capacity sharing and the cost benefits of shared storage. So let's dive into the Exadata X9M platform. Exadata X8M that we released in October 2019 was the world's fastest database machine. Well, we just made it faster, a whole lot faster. A whopping 70% increase in OLTP IOs per second compared to the previous generation. And this stops in at now 27.6 million read IOPS. And mind you, these are actual transactions measured at the SQL layer and not some kind of a micro benchmark, which means that this 27.6 million read IOP level is achievable by you in a real world application. But more important than that number of 27.6 is what does that mean to you? With that kind of a performance that's available inside the system, it is excellent for running some of your most mission critical transactions through the Exadata system, but more importantly, be able to consolidate multiple OLTP databases onto this on a single Exadata X9M platform. Thereby, you can get the maximum benefit and the return of investment from the Exadata platform. You can size the system for your today's workload and the scalability of Exadata, which is legendary, which allows us a linear scaling of the performance of the system as you add more capacity, means that as your business grows, you will be able to scale the system along with the growth of your business, thereby continuing to get investment protection. We talk about the 19 microsecond latency when we release the Exadata X8M, and I will be giving you a very quick look into how we achieve that. But before we do that, let's take a quick look at the competition and see where they stand. In terms of OLTP read latency, ours comes in at 19 microseconds, whereas the other ones are at least 5 to 7.5x slower than the Exadata X9M. And then when you look at the throughput side, we are 3.6x to 50x faster in terms of OLTP read throughput. So how do we achieve all this? And specifically that very low latency of 19 microseconds has been made possible by the introduction of persistent memory and combining that capability with remote DMA, which we deliver over the RDMA over Converged Ethernet fabric. The persistent memory has been expressed in the storage tier, and we always make sure that we automatically manage and deploy the persistent memory inside the system. We always store the hottest data in the persistent memory. So when a data block needs to be read, we issue a read command, which is expressed in the form of data accelerator algorithms that issue an RDMA read directly into the persistent memory and reads from the persistent memory directly without the intervention of either the operating system, IO interrupts, or context switching, which makes this entire round trip be fast. And that is what delivers that 19 microsecond read latency that I mentioned in the previous slide. For OLTP write transactions, we store the most critical portions of the OLTP redo log write into the persistent memory. And for high availability reasons, we also multicast that write into multiple storage cells, thereby maintaining coherency of that data in case of any inadvertent failure on the remote storage server during the write operation. This implementation of shared memory is the world's only shared persistent memory implementation for Oracle databases. And that is what delivers this level of performance. And that's what also allows us to get that 27.6 million read IOPS. Switching to analytics, the world's fastest analytics machine just got even faster. With the Exadata X8M, the product boasted 560 gigabytes per second. With the release of Exadata X9M, we made that 87% faster, breaking through the 1 terabyte per second throughput mark for SQL read throughputs. Again, this is measured at the database layer, not a micro benchmark. How did we do this? Well, we did this with a combination of both hardware improvements as well as software algorithms. The hardware improvements brought in an increase of 33% more CPU cores, a corresponding increase of 33% in memory bandwidth, matched with an increase of 33% in memory capacity, and a near doubling of the I/O throughput, which we take advantage of both on the RDMA over converged fabric, as well as the flash that is used as a caching tier for SQL processing. And again, similar to OLTP, the performance of this scales as you add more resources, both compute as well as storage, to the system. Looking at how the competition fares on this, 6 to 80x faster on Exadata, which means for every dollar that you spend, you are getting more from that dollar when you are implementing Oracle database and data warehousing and analytics workloads on Exadata. It was not just that. There were several other improvements that we made to make the world's most cost-effective database machine even more cost-effective. We introduced with this system a 28% increase in storage capacity, going from 14 terabytes to 18 terabytes. I already talked about the increase in CPU and memory and the memory bandwidth, as well as moving from the local storage, moved from using rotating media over to NVMe Express drives. We are delivering all of these as absolutely no change in price, which means when you look at an investment in Exadata X9M with the consolidation capabilities, the increased OLTP, and the increased SQL bandwidth, you are getting more for your investment than you ever have from Exadata, and nothing in the competition comes even close. Let's take a look at some of our customers who will be deploying these and using these software algorithms to its maximum. The details behind these software algorithms will be delivered to you by Kothanda in the next portion of this session. Exadata has always been a jewel in banking industry, where today we've got 10 of the top 10 banks running their transactional workloads on Exadata. National Australia Bank, Deutsche Bank, and Zurcher Kantonalbank Bank, all world-famous banks, use Exadata, and I'm picking these three as examples of customers who have benefited from the Exadata system. NAB basically adopted Exadata around 2013, and they have been on their Exadata systems to run their most mission-critical banking transactions on Exadata, and recently have started adopting the cloud platforms as well to reduce some of their costs in their own data centers. Deutsche Bank similarly had moved to Exadata in 2010, and the most impressive part about the Deutsche Bank implementation is they have not suffered a single unplanned outage on Exadata since 2010, and they also take the benefits of our cloud environments and cloud offerings, where we encrypt the data all the time, which is a highly sensitive requirement for the banking industry to make sure that the data is secure. With the Exadata X9M and the associated software algorithms that come along with it, we have delivered speed up in the decryption algorithms that Kothanda will talk about soon. Zurcher Kantonalbank Bank uses Exadata for both OLTP and data warehousing, and their performance has doubled since the time that they moved on to Exadata. Moving to telecom, when we think of telecom, we think of scale because of the number of subscribers and users and the types of services that telecoms around the world deliver to the world's population. I think the importance of telecom infrastructure and the agility of telecom infrastructure has never been put to more test than the events of 2020 and 2021. Vodafone moved all of their Oracle databases to Exadata in 2018 and continue to take the benefit and reap the benefits of a 2 to 3x reduction in SQL processing times. Swisscom, they take advantage of Exadata's multi-tenant capabilities and database consolidation capabilities, where they provide end-to-end tenant isolation, and they have reaped multiple benefits from backups to standardization to reducing their operational expenses and creating an entire business unit out of using the Exadata system to deliver value-added services to their customers. NTT Docomo, serving pretty much the whole of Japan, has seen a 10x performance increase combined with a 50% reduction in operational costs and a 90% reduction in data center real estate after moving their workloads onto Exadata. The energy sector depends heavily on the reliability of that infrastructure, not just the energy delivering infrastructure, but also the infrastructure that is used to maintain and manage the energy infrastructure. The companies that you see here continue to benefit in terms of the power and the scale and the reliability of Exadata systems across the markets and the geographies that these energy companies are operating in. But before we go into the details on what Kotanda has to share with us, let us hear from a customer who has adopted Exadata for running their day-to-day operations before we shift over to Kotanda, who will give us the details on the software algorithms. Thank you.
Equinix is the world's digital infrastructure company. Equinix has had tremendous growth. We've had doubled in just the past few years. With that growth and scale, our CRM platform, which is Siebel, was a challenge. If you have performance issues or outages, it has a huge impact. It impacts the majority of people at Equinix doing any type of operational role, from sales all the way through servicing our customers, which is why performance was a problem we were chasing for a couple of years before we got onto Exadata. We tried everything else. I've personally seen a benefit of no longer receiving executive escalations around Siebel performance. More importantly, Equinix has seen the efficiency gains of 30 to 40% improvement of the application across thousands of employees. And on large batch processing workloads, it's up to 4 and 5 times faster. We realized all of these benefits without changing a single line of application or database code. We've consolidated all of our databases onto Exa, and we're reaping the benefits across a number of services that weren't originally planned. We reduced the number of databases by 51%, from 287 to 138. We've improved the performance, as well as reduced our administration time, as well as improved our uptime. We've lowered the cost. All in, we've saved roughly 50% by replacing our legacy solutions with Exadata. By deploying Exadata in a hybrid architecture, we have the freedom to take advantage of a variety of cloud providers while keeping control of our data. Exadata allows us to be quick to respond to any demand that comes our way.
Exadata software is the secret sauce in enabling incredibly high performance, mission-critical availability, and the lowest cost for customer workloads. Let's take a look at some of the new features that make the software even better. The innovations in Exadata software span a large spectrum of use cases and workloads. After pioneering SmartScan to deliver incredible performance for database workloads, we have added unique features that enable SmartScans for much more complex queries and a much higher degree of parallelism. Subban talked about how the performance of the Exadata X9M provides a much higher throughput from Flash, and we wanted to ensure that decryption is faster even at such amazing speeds. The storage index and columnar cache persistence provide stable and consistent performance for analytic workloads across planned and unplanned maintenance. We have added additional management features to make it extremely simple, and we have support for newer algorithms in Oracle Machine Learning, graph and spatial workloads, and performance improvements for in-memory workloads and blockchain tables. Recall that storage indexes are created dynamically at runtime and automatically optimize the performance of queries. The storage index data structure can hold a minimum and maximum value. It can actually hold a lot of them. It can hold Bloom filters. It can hold other interesting and clever metadata that it forms dynamically. The format that the storage index chooses is based on the type of the data and the type of the queries, and the system automatically learns and figures out the best summaries to use. In this example, you can see that the first block has 3, 1, and 2 for column B. And if the query is looking for a value of 5 for this column B, the query can automatically skip processing the first block. This results in a tremendous amount of I/O savings since the data block is not read in, and a tremendous amount of CPU savings as well, since we don't spend the CPU processing the block. Customers have grown to love the feature so much that they rely on it significantly for consistent performance of analytical queries. In this release, the storage index present in memory is stored back on the disk when there is a planned maintenance of the storage server. When the storage server comes back up, it reads this again and starts up where it left off. This results in consistent performance for queries across storage server updates. Also, note that the storage index is stored encrypted both in memory and on disk. Now, let's take a look at persistent columnar cache. The hybrid columnar format on hard drives is converted into the in-memory columnar format dynamically and stored in the flash cache. This ensures that we can run queries extremely fast using the vector processing instructions. Starting with Exadata System Software 21.2, the columnar cache is persisted in the write-back flash cache. This ensures that on a storage server restart, the columnar cache can be reused. Persistent columnar cache works for both planned and unplanned maintenance scenarios. This ensures that customers get the same amazing and consistent performance all the time. Now let's take a look at SmartScan metadata sharing. As the core count of the database server grows, there is naturally an increase in the degree of parallelism for the queries. This in turn increases the amount of metadata the storage server needs to hold and process. In addition, as we increase the complexity of the queries that can be SmartScan, the metadata becomes even larger. For example, Bloom filters are larger, the data mining models are larger, and the JSON queries send much larger metadata. In order to scale to those needs, the storage server has the ability to share metadata across all of these parallel processes that are working on the same set of queries together to improve scalability and performance. This happens automatically and transparently for all database versions that exist. That's just incredible. We looked at the performance of Golden Gate trail files and we thought we could improve that. So let's look at how Golden Gate writes to trail files. It performs a lot of small IOs. This is then written to the file system by ACFS as a large IO because it coalesces all these small IOs, and that can end up skipping the flash cache and going to disk. With Exadata System Software 21.2, the storage server identifies ACFS IOs and automatically caches them without affecting other OLTP workloads. So when Golden Gate comes back and reads those trail files, the performance can be up to 7 times faster since it will find the IOs in the flash cache. There's no need to set up a special IO resource management plan. It just works transparently. While using transparent data encryption, which is the default for all cloud deployments, all the data on flash is encrypted. As the flash throughput doubled this year with X9M, we didn't want to spend twice the amount of CPU to decrypt the data. Intel added a few new instructions in X9M to improve decryption performance, but our performance measurements showed that we could do a lot more. In the first picture, you can see that there's a decryption module on the right. The decryption module decrypts to a temporary buffer and copies it back to the source buffer. This ensures that if the data doesn't need to be decrypted, the functions would just work. The problem is that the copy back to the I/O buffer uses up memory throughput, and the system can get memory throughput bound with the new flash driving higher throughput. Instead, we pipeline the decryption stage such that there is no copy back, and that improves the performance on the X9M by up to 2.4 times. This optimization also helps all older generations of hardware and works with all the versions of database software, making the system faster for everyone. Managing Exadata systems just got even easier. On the networking front, we added automatic service requests for Rocky Network Fabric switches, and we made it easy to update the management switch using the integrated software update. The integrated lights out management software is pre-staged on the server, decreasing the amount of time it takes to upgrade by over an hour of a full rack. Diagnosability got much easier with unified list alert history command that shows a timeline of various alerts, including hardware, Exadata software, Oracle Grid Infrastructure, and Oracle Database Software. Oracle Exadata introduced secure fabric isolation to keep virtual machines isolated. Virtual machines can communicate to a shared storage server, but even if they're in the same host, they will not be able to communicate with each other. This allows virtual machine clusters to stay isolated from each other on the same server. This network isolation is done by the network card on every packet and cannot be bypassed. All the rules are programmed by the hypervisor automatically. This allows for a completely software-defined network in a large data center with extreme isolation between virtual machines on the same server. In the picture shown, the sales virtual machines can communicate with each other, and the HR virtual machines can communicate with each other. All the virtual machines can communicate with the storage, but the HR and the sales virtual machines will not be able to communicate with each other. And that is the amount of security that we have. Smart Flash Log Write-Back. As we all know, redo log latency is critical for OLTP database performance. In the picture shown, the original Smart Flash Log feature would perform a redo log I/O to either the flash or the hard drive, and whichever completes first, it would complete the redo log I/O. This ensured that the redo log I/Os got the lowest latency possible. The new feature, Smart Flash Log Write-Back, improves redo write throughput. Take a look at the picture that's labeled now. Instead of writing the logs directly to hard disks, the redo logs are written to a different flash drive. And the redo log I/O is considered complete as soon as the lowest latency I/O completes. Eventually, the I/O from flash cache is destaged to the hard disk. The advantage of this is that the workloads with very high redo log throughput get excellent performance since the redo logs are written to flash. Write-back flash cache is needed for this feature, and it is the default in all the deployments in Oracle Public Cloud and Cloud at Customer. The columnar cache works by converting the on-disk hybrid columnar format into the in-memory columnar format on flash and processing the data from flash at amazing speeds. With this new feature, the hybrid columnar data is added to the flash cache using a simple transformation, and the columnar creation happens by reading the data from the flash cache. Since the in-memory rewrite engine is reading data from flash cache, it significantly speeds up the in-memory columnar format build. The feature is a win by itself since it improves performance. Not only that, it improves the performance of other workloads that run on the system as well. For example, a backup running concurrently now runs faster since the amount of data being read from the disk has been reduced. This feature is used all the time in the autonomous database shared now, and it's completely transparent to customers. Data is moved out of a storage server and moved into another when a disk fails. This can also happen when a storage server is added and the new capacity needs to be filled up. This process of moving data is called rebalancing. Oracle Exadata X8M and X9M have persistent memory to cache the data. Starting with Exadata System Software 20.1, when Rebalance moves data from one storage server to another, it checks to see if the data was present in the source server's persistent memory cache. If the data is present in the source server's persistent memory cache, the data is inserted into the target storage server's persistent memory cache. This ensures that the workload gets consistent performance regardless of storage reconfigurations. This is critical for OLTP applications that demand low latency. There are a number of other features, such as controlling whether persistent memory cache or persistent memory log is used for a specific database or not, and the move to Jetty that makes the management server much more lightweight. Exadata X9M is now the world's fastest database machine. It is much faster for OLTP and analytics, and since it is the same price as the previous generation, for so much additional performance in I/O, CPU, and networking, it is far more cost-effective. The Exadata Smart System software continues to deliver impressive features. The new software is much faster, easier to manage, and provides extreme security. This makes Exadata X9M the best platform to run the Oracle database.